Just start here a little early.
So you weren't here on Friday. I generally do post recorded versions of lectures, but I was having some issues with Zoom. I believe I've got it fixed. You can obviously see the screen today as I'm using the app. So, I guess that kind of highlights the importance of, things happen. There may not always be that recorded lecture. I just kind of do that as supplemental material. So don't kind of rely on that. Although generally I will be able to get those up there 5+% of the time, right? So today we'll have one, but it does kind of highlight the importance of showing up. Also, we'll be using iClickers today. So again, to get those participation points, it's another good reason to show up in class. I'm already a little concerned counting the numbers today on how many people are already out. So we'll jump back into some new material, some slides. We're doing a lot of work in Excel again today. So kind of a crash kind of course. I got kind of thrown in there pretty early, so we get kind of comfortable and used to seeing how we work through things in Excel. Also, just to kind of reiterate, that Connect assignment is currently up there. The due date's quite a ways off, but especially even after today, you can probably start chipping away at a lot of those questions. I'll also put the first Excel assignment up when I get back to my office after I'm done teaching today. That'll be a lot of what we did today, right? And I won't be able to work through the entire thing completely yet. We still have a little bit more stuff we have to go over, but you make it pretty good.
Once you start for the assignment, can you get out?
You should be able to always save along the way your work and then always go back and pick up where you left off. So.
Any other questions? All right. So let's start getting into it here today.
Last class, so we're doing an example in Excel where we looked at discrete data, right? So we're like counting the number of people who tried e-cigarettes at age 8, exactly equal to age 9, so on and so forth. Continuous data is a little bit more difficult because if I wanted to do that, and let's use income as an example. If I wanted to count or do a frequency distribution for income, I'd have to count the number of people who make $0, the number of people who make 1 cent, the number of people who make 2 cents, all the way up to whatever Bezos is making, right? Well, I'm going to have like a ridiculously high number of categories. It doesn't make any sense to be able to visually show the distribution of the data if that's how I treated continuous data. So what we're going to do is create these things that we'll call bins or classes. Instead of counting the number of people who try to e-cigarette at age 8, will be like the number of people who make between, I don't know, let's just do 0 and 20,000, right? So I'll go through the data and count every single observation that's somewhere in the range of these two values. Okay. Well, once I do that and I create all these different bins, imagine I keep going 20 to 40,000, 40 to 60, all the way up to whatever the highest income is in my data set. I'll then have all these frequencies. It's just like what we were doing before. I then just kind of throw them into this column or bar graph, and I have this nice frequency distribution, right? That shows me where does the majority of the data lie? Where does the majority of income lie? Is it in these lower bins or in these extremely higher bins? Or in that one, we kind of already imagine the frequencies are going to be lower when we're looking at higher income values. Okay. Now, what we'll call this, is a histogram. So just a kind of technical term that if I'm taking continuous data and then forcing it kind of when I'm counting frequencies into these bins, when I graph these bins, we don't just call it like a column or bar chart. We're going to call it a histogram, just a fancy name for it. Right? But it's the same process, right? Once I have those frequencies, like in Excel, just like last class, I just highlight them, insert a column or bar graph. That's my histogram. Okay. So a couple things we'll have to do. First of all, how many of these bins am I going to use? And I was just saying 0 to 20,000 here. Well, how was I coming up with that bin length? Okay. So generally, we're going to want to keep the number of bins or the number of classes. I'll generally say bins, but those two terms are interchangeable. Somewhere between 5 and 20. You kind of imagine if income, if I did do this, like 0 to 20, 20 to 40, 40 to 60, I'm still going to have way too many bins because I have to continue to do that $20,000, bins all the way up to whatever Bezos or Musk is making, which is, in the billion at this point. I don't even know how much annual they're making, maybe in billions, right? I'm still going to have way too many categories. So I want to try to create them such that I'm somewhere at 20 or fewer bins. Otherwise, I'm just going to get way too long of a graph, or way too wide, I guess I should say. Probably want more than 5 to actually get like an interesting snapshot of what the data looks like. Think about if I did like 2 bins. So the number of people make between 0 and 100,000, and number of people make
more than 100,000. That's not a that's not telling me very much about the data. I'm just going to see like a large mass of people under 100,000 and then a smaller mass over. Right. So I want to get kind of more of a I don't want to say this, kind of more of a granular kind of look into the data. I want my bins to be somewhere between 5 and 20. Now, when it comes to like homework assignments or Excel, I'll tell you what that number is. In practice, like you kind of have to use some of your own intuition, and we'll see that a little bit in the Excel example today about what our bins should be. So there's no set rule. We then have this optimal bin length calculator. So before I was just choosing like 20,000, right? Well, how was I coming up with that? I was just using that as an example. The bin length should be determined by this formula, right? So all you're going to do is take that maximum value, subtract the minimum value, and then whatever that range is, divide it by the number of bins you want, and that will be your optimal bin length. So we'll work through an example in Excel where we do this and we kind of use this optimal bin length. In practice, we might alter it a little bit. This will kind of be like our starting point. So hopefully today we'll have enough time. We'll get kind of like a complete snapshot of how we would approach this, like if you were doing this outside this class. You'll start with that optimal bin length formula. But then, let's say for income, let's say it was like, I don't know, $34,321.52. Well, if I'm creating my bin lengths there, I'd have to go from like 0 to 34,000, whatever I said. Those aren't going to be really nice numbers to look at, right? And I might want to like have something that makes a little more sense, like 30,000, right? Cut it off like one of these nice 10,000s. So I'll use that optimal bin length as a kind of starting point. But I then might kind of say, well, what would look nicer visually, right? If I do that, I've got a couple things I need to make sure are true. If I use the optimal bin length, these following things should be true. But if we change it a little bit, which I'll show you an example today, we have to make sure these other 3 things are true. But first, we need to make sure that they're mutually exclusive. So really the only way we can screw this up, so all mutually exclusive means is that any observation can only be counted in one bin. So how can I make a mistake? Well, let's say I did something like this. Are those bins mutually exclusive? No. There's numbers, and I wrote 10 here because I'm thinking and not thinking and writing at the same time, right? There's numbers that are in this range, maybe 15,000. That's also in the first bin, right? So I need to make sure they're mutually exclusive. So I might think, okay, well, if I just start where the last bin left off, everything should be mutually exclusive. What's the problem here?
You're gonna have 20,000 in each bin.
Yeah, right. I have to be really careful with my equalities, right? So to make sure that they're mutually exclusive, the equality can only be on one of those bins. So that's really the only way that we probably make errors really with this mutually exclusive idea is that, yeah, the next bin starts where the last one left off, but it doesn't include that value, right? Technically, it's anything greater than that, which if we're doing income would be 20,001 cents, right? But if we had something that was truly continuous, like measuring height, and it could go out to whatever decimal we want, we don't actually know, we can't put, I don't know, 55 inches, 0.00000001. We'll just use that greater than sign. That way we know we're capturing any decimal, right, above that value. Okay. So mutually exclusive, be careful with the equalities, and then exhaustive. So this one, once we work through the example in Excel, I think will make a little more sense. But like with income, I kind of already mentioned it. If we're doing like $20,000 jumps or $10,000 jumps, we're still gonna have way too many bins because we have to go all the way up to that maximum person's income. Well, what if I did something like 0 to 20, 20 to 40, 40 to 60, but then I know that if I look at the data, there's not a ton of people who make more than 100,000. So I'll just create this catch-all category, which basically I'll kind of get this nice frequency distribution up to 100,000, and then just anyone greater than 100,000, I'll count them in this last category. Right? Now, like I said, the example we have today will kind of highlight why this might be useful. Okay. And then the last thing, we generally want to try to keep the bins the same length, with the exception of if we create one of these catch-all categories. Okay. Any questions over anything here yet? Shouldn't be too bad. Like I said, we'll get kind of a nice visual. So one thing I want to do today is kind of make sure that if you have registered your iClicker, everything's working correctly. Also for me to make sure, that I've got all the settings right, because it's I'm bound to make one error.
we'll kind of do this IQ question today. Have recorded responses for you. So I didn't go over this, I think, explicitly when I was mentioning them last week. So the way that I'll score these, right? There's 10 points every time I use them. Let's say we had 3 questions. You get, just for answering them, you get 7 out of the 10 base points. And then for every question you get correct, I'd add in a point. Right? So if you get all 3 correct, you get all 10 out of 10. If you get all 3 wrong, you still get 7 out of 10. Right? So as long as you show up, you're getting a pretty good majority of the points. Sometimes I only have 1 question. So there, you know, if you get it right or you get it wrong, you're still getting 9 out of 10. Right? So usually I work through one, but work through this together, try to make it today's easy. Really, like I said, this is more of like a troubleshooting thing for me. So if you've got the app, it should show up this class in this section. Anyone having issues with that? You got the app? Yeah.
That's section 1 for 2023, but only section 2 for 2021.
Oh, hold on. I might have just made a typo. Let's double check this. Yep, I did. Here, let me thank you for saying that. Where's the name? I'm living in the past, I guess. All right, so let's try this again. Maybe. Now let's start this. This is the reason why I'm doing this today. Right? So hopefully it's showing up and it looks correct now. Yeah. Yeah.
Is there like a frequency that we gotta hit?
Yeah, so good job, you got. So we got that right. The physical, no, you're good. No, this is already, you're asking the right question. It's the next thing I was gonna say. So the physical one, if you're using that, I always keep it on AA, like the frequency. So if you've got it set in something different, or like it says, I think it'll give you like an error if it like I don't forget what it says, but some error on there if it's not able to kind of pick this up, you'll have to change your frequency to AA, which is you hold the power button until it like starts like flashing. There'll be like a little, I think, bracket parentheses, and then you just hit AA, and I always leave it on that frequency, right? If other professors tell you that they change it, it's just because they're lazy. It's pretty easy to throw people out if they're not in the class. So I just always keep on AA. It makes it a lot more simple for you guys. Okay. I shouldn't throw people on a bus like that, but it's pretty easy. So if we want to calculate the optimal bin length here, right? What am I going to do? So we go back to that previous equation. All we're going to do is take our minimum, subtract the maximum, and divide by the number of bins, right? So if I've got this data where I've got Indiana schools and their SAT scores, I see the minimum value, some school had only 352, maximum 648, and I want 9 of these bins. It's a matter of plugging in my values, right? So I won't even write this down. I'll make it kind of easy for everyone today. Maybe, there we go. So I plug in my maximum, I plug in my minimum, number of bins that I want to use, and I get my optimal bin length should be about 32.88 repeated. Okay. So this is, I want to highlight 2 things, especially for as we kind of continue to work through things throughout the semester. Sometimes I'll show you the answers, and I'm only going to show you them out to the second decimal. If you did some like rounding error wrong or something, you might be off at like the second decimal. I'm never going to try to trick you and give you like 32.88 or 32.89. I'm not even like, even in this one, right? I'm just kind of having that to the next integer. I would never put like 33, 34 up here, right? So as we kind of progress through working some, we're going to be, you know, we might be really close. Generally, whatever answer you have, it should be at least within that second decimal, right? So if I'll kind of mention this if that's the case too, once we get to some stuff where we're doing more intermediate calculations and you might round things on your calculator. So hopefully everybody gets this one right today, right? We've got the optimal bin length here. We should have like 33, right? So hopefully everyone has a response in here. Got 29. I thought I counted a little bit more, but we'll kind of make sure. So make sure you get a response in here. Close it out. So we got 29 of us. All right. And then I'll sync these up this afternoon. If there was any issues with kind of registering it and kind of getting it synced up, I might reach out to you individually because usually I can kind of figure out who that is. Like I see you as a number, but I also see, you know, that you're in the class, and I can generally like send out an email to a small select number of people like, hey, can you give me your physical version, or is the app, make sure, you know, if you're using the app, was it showing up? That way we can kind of make sure I'm getting everyone synced up for classes moving forward. All right. Starting on Friday, probably won't just be giving you the answer. Okay. I'm just kind of troubleshooting it here today. Okay. Any other questions on that before we kind of keep progressing here? All right. So
Now that we know how to find these optimal bin lengths, we'll talk a little bit about kind of what this looks like. How do we do this in Excel, right? Because we're not going to do this by hand. If I've got data sets that are in the thousands, I can't count the number of observations, for income in between 0 and 20,000. Like, let's say if I had the population data set from the IRS, right? So what can we do? On Canvas, under files, I added a couple of folders in here. So in-class data is going to be just where I put any data that we work with in class. And then as we get to like each exam, I'll like create another folder, which is like exam 1 data, exam 2 data, things like that. So here was the blank file. I've been uploading kind of as we've worked through stuff. I've just uploaded like what we've done in class. I'll upload this, kind of replace this file after today's class. That'll have not only what we did on Friday, but also what we did today. Right? So if you want to start with this, it really doesn't matter either one, because once we open this up, instead of using this user's discrete worksheet down here, that's what we did last class. I'm going to go over to tuition continuous, right? So that's the worksheet that we're going to use today, okay? So what I've got here, well, actually, let me zoom in so you can see what I'm doing first. So once again, I think I mentioned this last class, but if I'm in between two columns and I get this like kind of symbol where I've got arrows on either side, if I double left click, it'll auto adjust so that it kind of shows me what the entire name of this variable is. So here I've got a bunch of different colleges. I didn't include their names. I just have their ID numbers according to the, who is this by? I think iPads, something post-secondary education. And it had like the net price of attending, the annual attendance for each one of these colleges, right? So we've got a pretty big data set. Just as kind of a way to look at it real quick. If I hold Control Shift, Command Shift on the Mac, hit the down arrow, yeah, I've got like 3,500 observations, right? Go back up to the top here. So if I want to find the minimum maximum, this is going to be a problem, right? I want to hunt through this to try to find the minimum maximum. We said last class, we've got those nice built-in functions. So why might I want the minimum maximum? Well, I eventually want to kind of create 8 different bins, get the frequency for each one so I can get this frequency distribution of the data, right? So I need the minimum and the maximum, and I also need to know, well, how many bins do I want? Well, here I'm telling you 8, right? In practice, you get to choose this, right? But for here, we'll just assume we wanted to do 8, right? It's not too big, not too small. So I use that built-in min function, select the very first observation, hold Control Shift, Command Shift on the Mac, hit the down arrow. It goes all the way down to the very last variable. Now I can scroll all the way back up and close the parenthesis, but a nice, easier kind of shortcut is if I just hit enter here, it closes the parenthesis for me and sends me back up to the top. Another way to kind of show you the important, or a nice usefulness of just hitting enter. Let's say I wanted to just, I don't know, add these 2 values together, right? Well, if I want to get out of that cell, a common mistake that I'll see people make is they'll just like try to click somewhere else. Well, if I just click somewhere else, notice it's like throwing in cell references there for me. So instead, if I just want to add these 2 values together, and then I want to get out of that cell, instead of clicking off somewhere, the best way to do it is just hit enter, right? So anytime, you want to get out of a cell or kind of close that parenthesis, hitting enter is going to be your best bet, okay? Any questions in that? Keep moving. Now, obviously, this is not the maximum. I was just using this to show you something, so I'll delete that. We want to find the maximum. We said last class, well, that's just the built-in function of max, right? Start my parenthesis, select the first observation, hold Control Shift or Command Shift on the Mac, hit the down arrow. Once again, now if I hit enter, close the parenthesis, sends me back up to the top. Okay. So I now have everything I need to calculate that optimal bin length. Okay. Any questions on anything up to this point? Okay with that? So I'm going to move this down one just because no, I'll leave it here for the sake of, I think I have the slides that match up with this. So if I want to calculate this optimal bin length, I just need Excel to do some math for me, right? There's no like built-in bin length formula, but I've got everything I need in order to calculate that. So I'll take my maximum value. Instead of typing it in, I can just select what cell is that maximum in. Subtract my minimum value, and then divide by, and here I need to change mine for future classes, but I think I wanted to make sure that I remembered. So sometimes it'll default to like widening
when you're using like using Excel to do math or built-in function, it'll like widen this. So it's kind of covering up that number there. It's still there, right? But a lot of times Excel is set to default for that. I forget off the top of my head how to change it, so I'll bring that in next class so I can kind of let you know if that is what's happening with yours and you are kind of getting this widened cell thing, how to kind of change it. Because I think it defaults to that on most like I don't know if the Mac one does, but I know the PC one does. So if that's the case though, yeah, I can't, it's not nice. I can't just like select that cell now, but I know that cell is in E3. I can always, don't have to just select the cell. I can always type in what that cell reference is. Right? Now, if I do this, what's the problem going to be? Yeah. Yeah, I got, even when I use Excel to do math, I still have to worry about order of operations. This is going to first divide the minimum by the number of bins and then subtract it from the maximum. So if I hit enter here, I get a bin length that's like almost equal to the max. So hopefully I look at that right away. I'm like, yeah, that doesn't make a whole lot of sense, right? So I go back in here. Oh yeah, I need to first take the difference of the maximum and minimum. So I'll put parentheses around that. So a lot of times I tell people when we're doing work in Excel, overusing parentheses often is like a good way to avoid order of operations errors. So even if you're not sure, kind of making, using these parentheses can be helpful. Okay. Any questions on that? So now if I hit enter to get out of that cell, I get my bin length should be about 8,500, right? So we're going to first build it out using that optimal bin length. And then I'll show you, well, what if we wanted to use like a nicer, prettier number, right? Maybe something like 5,000 or 10,000. Right? So what we're first going to do is create two columns. So here I've just got my bins labeled 1 through 8. What I want to do is think about where does each bin start and stop. So my very first bin, if I'm using this optimal bin length, is going to start at whatever the minimum value is, which I think here we had was 200. Right? And then so let's say that's where that bin starts. All I'm going to do here, instead of typing that 200 in, is use the cell reference, right? That first bin is going to start at whatever the minimum value is. Hit enter to get out of that cell. Where should this bin stop? If my optimal bin length is 8,571, where should this stop? Yeah.
8771?
Yeah, right. So what you do there, you just added that bin length to wherever the bin started, right? 200 plus that optimal bin length, which should give us that 8,771. So what will I do in Excel? Well, I'm just going to take where does that bin start and add to it whatever that bin length is, right? If I wanted the bin length to be 10,000, well, then the first one should go from 200 to 10,000, right? So that's all I need to do, right? And then I'll show you why using those cell references. So how we can exploit those is really nice. So I'll hit enter here. I've got the start and the stop of my we'll have just a little bit more work to do, and then we can use kind of these cell references updating and copy this to prevent you doing a lot of extra work. So the next bin is going to start where the last bin left off, but I have to be careful about what. So let's say I do this, starts where the last bin left off. What's going to be the issue? Got that equality. So if there was a school that had the net tuition of 8,771, it'd get counted twice. So I'm still going to use that value where the last bin left off, but just strictly greater than. And then where would this bin stop? Well, start at 8,771. I would then add to that whatever the optimal bin length was to get where that bin stops. So how do I do this in Excel? Well, this bin, the second one, starts where the last one stopped, right? So the minimum of this bin is the maximum of the old bin. And then here, once again, well, it's just take where that bin starts, add to it whatever that optimal bin length I need is. Now, I can copy these down, and this is going to be great, right? Because this was F8. Well, where is that third bin going to start? Well, it's going to start where the second bin left off. Well, notice if I copy this down one row, my cell references update one row, so F8 becomes F9. So I can just copy that down and it will always be using the maximum from the previous bit. So that's great. I can copy that down. That should work. So give me 1 second to do that. There we go. Well, I got a bunch of zeros in here. Why? Well, because I haven't put the maximum of the other bins in yet, right? Excuse me. So if I think about that second bin where I just, okay, where does it stop? Well, where does it start? Plus the optimal bin length. If I copy this down, well, yeah, I want E9 to become E10 because that's where the next bin starts. But I always want that cell reference of E4 to be whatever that bin length is. So what do I need to do to E4? What did we use last class? Do you remember? Yeah. Yeah, throw dollar signs in there, freeze it, right? Or select it, hit F4 on a PC, Command T on a Mac, and it'll automatically throw those dollar signs in front of that row and column heading and freeze that reference. So now when we copy it, that'll stay the same, right? Because we always want to keep using that same optimal bin length when we're calculating where each bin stops, or the maximum of each bin. Okay. Also, someone asked me, might have been from this section, I think they had a MacBook Air. If Command T isn't working for you on a Mac, some of the Mac, I think it's the Mac Airs, actually have F4, like F keys. So it's the same as a PC where you'll hold like a function or an FN key and then hit F4. I don't remember every model and whatever it is which. But if that Command T is not working for you on a Mac, you might have an F4 key up there at the top. Okay. Any questions on this before we keep going? So now when I copy this down, the next one becomes E9 becomes E10, and I'll just add it at the bin length. So I don't have to type this in every single time. I can just left click, copy this down. I now get the minimum and maximum of each one of these 8 bins. Where should my last bin always stop if I'm using this optimal bin length? If I've done it correctly. Should stop at the maximum value. Sweet. I can double check that, right? I must have done it, or at least didn't make any egregious errors here, right? Because I'm stopping at that maximum value. So how do I come up with my frequencies? Okay. Well, last class we used the count if formula. The only problem was I could only check to see if one criteria is true. Here I need to check to see for this first bin, is it greater than or equal to 200? But I also need to check a second criteria, which is it less than or equal to 8,771? If I just use the count if formula here and count the number of observations greater than or equal to 200, what should that do? That should count how many of the observations are going to be greater than or equal to the minimum. Every single one of them, right? So that's not what I want. So instead of using this count if, I'm going to use the count ifs, right? I have multiple criteria I want to make sure are met. Okay. So the first thing it kind of lets us know we need to do is, well, select what range you want to check this criteria against. What range of data do you want to make sure is greater than or equal to this minimum value of 200? So we'll go up here, select that very first cell, Control Shift, hold Command Shift on the Mac, hit the down arrow. Now, I had to scroll all the way up, which is kind of annoying on a laptop. If you want to, this formula bar, you can type things in here too. So like I could do comma and then start, I want to make sure is it greater than or equal to 200. I'm not going to use the formula bar in class just because it's small and I can't change the zoom on that. So I'm going to scroll back up to show you what it looks like. But you can just use that formula bar if it's easier on a laptop. I do that a lot when I'm doing stuff for myself because it is annoying to scroll up a lot of times. So I selected the data, comma, what's the first criteria I want to make sure is true? Well, I want to know, is it greater than or equal to? We said last class, we use these equalities are now inequalities. We have to put them in quotation marks, right? So I have greater than or equal to. So we type it in just like we say it. There's no key that's a greater than or equal to sign. So we have to type it into Excel as greater than or equal to. Now I want to say greater than or equal to what? The value of 200. However, just in case I wanted to change things down the road, I'm I'm gonna use cell references. So let's say, I don't know, I get some new data and the minimum is not 200, it's, I don't know, like maybe I'm updating it every single year. And now the minimum kind of net tuition is, I don't know, 300, right? Well, if I use cell references, when I update that data every year, it's gonna update my frequencies accordingly, okay? So I'm gonna use not typing in the value of 200, but the cell reference where that minimum value is at. Then comma, one thing that's going to seem kind of weird, but for future stuff we're going to do, it might make a little more sense that this count if formula has multiple uses. But to check that second criteria, I'm still going to look back through the same data, right? It's the same variable. I want to check to see, was the net tuition greater than or equal to 200, and was it less than or equal to 8,771? So I'm just going to select the same data again. Seems stupid. Like I said, for stuff we do later on, there's a reason why we have to select, we might select different variables if we're kind of down the road. But for us, creating these histograms, we'll select the same variable. I could do it the same way to before, select the first cell, Control Shift, Command Shift on the Mac, hit the down arrow. Or if I can already see what that cell reference should be, instead of selecting it, scrolling back up, we can always just type, if I move my mouse out of the way, I can always just type in what that cell reference is. I've already selected it once. I know I want to go back through and look at the same data, the same variable. Right? And then comma, well, what's the second criteria? Is it less than or equal to, put that in quotation marks, and sign the maximum value of that bin, right? So for this first one, this count is formula, it's telling Excel, hey, go through the data, count the number of observations that are greater than or equal to 200. Then go back through that data and throw out any of the observations that aren't also less than or equal to this 8,771. Okay. So this hopefully will give us the frequency for that first bin, right? The number of observations in between these two values, 200, 8,771. Sure enough, it does. Okay. Now, I don't want to have to keep typing in this count is formula for every single bin. Here, I've got 8 bins, I could do that. But like, let's say I had 20 bins. It's going to take me a lot more time, right? If I've set it up this way, one thing I can do really quickly and kind of nicely update this, well, I'm always going to be using the minimum maximum of each bin. So E8 and F8, if I copy this down one row, become E9 and F9. Well, those are the 2 new values I want to use, right? The only problem is if I copy this down, what happens to the range of data? It also updates one row. And now I'm going to be missing my first observation. So I need to make sure I freeze wherever I'm referencing the data. Now, it'd be nice if I could select these both at the same time. There's not a way to do that and use the shortcut. So I'm going to have to select each one, hit Command T or F4, Command T on the Mac, F4 on a PC, or F4 on some Macs, and then kind of use that shortcut, and it'll throw those dollar signs in front of my row and column headings pretty quickly. Okay. Any questions on anything over there? It's kind of making sense a little bit. So if I hit enter here to get out of this cell, hopefully it still gives me the same value, 277. It's just that now when I copy this down, even down here, it's still looking at the same range of data and now counting, well, how many of the observations were in between the minimum and the maximum of the last bin, right? But I didn't have to type this in 8 times. I had to type it in once, make sure I froze the right things, and then I can just copy it down, right? Saves me a lot of time. Also, you can imagine how much time does it save me if I was going to do this by hand, right? Counting every single one of these. Okay. Any questions on that before I keep going? Yeah.
For the other one, couldn't you change it towards just greater than instead of greater than or equal to? That way it doesn't count.
You're right. I forgot that in this example. So it's a good point. What did I forget to do here? On that first bin, I want to make sure I include the equality on the minimum, but in every subsequent bin, that equality won't be there. So technically, when I copy this down, oh yeah, I actually don't want it to be greater than or equal to 8,771. I just want it to be greater than, right? So now if I hit enter and copy this down, it doesn't change the values here because, I mean, what's the chances that I get exactly that net tuition? But in examples like I might use in the Excel homework, yeah, we need to make sure that we're careful of those equalities. So good catch on that. I was gonna a little more focused on it over here, but yes.
right? That first one, we'll need to make sure we include the equality on the minimum value. And then for each subsequent bin, we don't need that equality on the minimum anymore. Yeah. Any other questions on that before we keep moving? So for the sake of time, I won't show you how we graph these because I'm going to show you how to do that in a second from our second example. Okay. So we're going to scroll over here. I kind of had all this typed out ahead of time. Instead of using that 8,700, 500, whatever it was, let's say, I look at this distribution and I say, okay, I mean, the bulk of my schools have a net tuition in these two bins, and there's not very many kind of up at the top, right? I mean, these are ridiculous, right? Like $60,000 of annual tuition. These are like crazy private schools. So maybe what I want to do is create kind of like a catch-all category, kind of make the data a little more granular at the bottom end of the distribution. But then for those like really high values, I know there's not very many of them. I'm going to create this catch-all category. So instead of 8,571, I'm going to use the optimal bin length of 5,000 and then create this catch-all category down here at the end, which is just any university that had a net tuition over 35,000. Okay. So we would do this the exact same way. So it's just getting another example of seeing how we do this, with the exception of here, I'm just going to start out at not my minimum value. Actually, I don't need an equals sign here. I'm just going to start out at the very lowest value of 0. So I'm giving us the bins here already. So it should make it a little bit easier, right? Start at 0. But then instead of typing these in, right, 5,000, 5,000, 10,000, 10,000, 15, I know that every bin is going to have this bin length that I've now chosen, which was 5,000, right? The optimal bin length formula was like my starting place, but, visually, these are going to look a little bit prettier. The labels look a little bit nicer, okay? So each bin is going to be, well, where does that bin start? Plus that optimal bin length. And when I copy this down, instead of L8, I want this to become L9. But I always want that bin length to be 5,000. So just like we did before, I'm going to freeze that cell reference. Right? So I should just have to type this in one time if I do it this way. So I'm not using the optimal bin length kind of formula, starting at the minimum. I can just start at 0, use this optimal bin length of 5,000, and then create a catch-all category at the end. Okay? So this should work now when I copy it down. And then the minimum of every single bin is going to be, well, where does the last bin leave off? Okay. Now when I copy this down, M8 to the next bin will become M9, right? So it's always kind of looking back to the previous bin. So if I now copy these down, hopefully I've done everything right. And the minimum maximum of each bin is kind of matching up with those labels that I had, those starting and stopping points for each bin. Okay. I've kept all the bins the same length, but I've also kind of created this last catch-all category, which should capture anything over 35,000. So this is where I have one small thing I need to then make sure. If I create a catch-all category, the maximum of the last bin shouldn't be 40,000. It technically should be what?
Infinity?
Infinity. Technically, I could just use the maximum value of my data set. That way I'm making sure I'm counting every observation up to the maximum. But just in case the data is changing year to year, right? One thing I might want to do is use infinity, which can't do that in Excel, but what I can do is put 1 and then hold the 0 key down for a while, right? Just make it this ridiculously large number that I know net tuition can never be above this, right? So it's essentially like I'm saying, just go off in infinity. Now, another way I could do this, I like to set it up this way, because then if I use the count ifs formula, when I copy it down, it'll work for every bin. I technically could do what we did before for every bin except for the last one, and then just use a count if formula and just count it if it's greater than 35,000. Either way is fine, right? Either way is going to count the same thing. I think if we just set it up this way, choosing a ridiculously large number by copying that count ifs formula down, we're going to save ourselves a little work. Okay. So just like we did before, if I want my frequency for each one of these bins, I'm going to use that count ifs formula. Once again, I can scroll over here, select the first observation, hold Control Shift or Command Shift on a Mac, hit the down arrow,
Now I could scroll back up or use my formula bar. So if you wanted to just start typing in the rest of this in your formula bar, you can. I'm going to make it a little bit bigger so you can see what I'm doing and kind of scroll back up here. So that was my look through that variable, count it if it's greater than, and I'm going to kind of cheat here because I know there's no zeros in the data, and I know that I don't want that equality on any of these minimum values. I'm just going to say, is it not less than? Typing and talking. Oops. Greater than, right? That zero value. So instead of typing in 0, I'm going to use that and sign and use that cell reference where that minimum value for the first bin is. Comma, I could select that variable again, or I can see, well, here's where the cell reference for that data is. So B2 through B3538, right? Comma, what's my second criteria? Is it, no, less than or equal to, right? Use the and sign because I want to use a cell reference here, which is the maximum of that bin. So this is exactly what we did before, I'm just using different bin lengths. So now when I copy this down, I should be good, right? I'm pausing because no, what do I need to make sure I do? Freeze what? The range of data, right? I always want to keep looking through that same range of data. So I have to make sure that those cell references, Command T or hit F4, throwing those dollar signs and freeze them. Now when I copy this down, always look through the same range of data, count it if L8 is going to become L9, right? So if it's greater than the minimum of that bin, go back to the data and count it if it's off the screen here, less than or equal to the maximum of that bin. Yeah.
What is it? One of them says 2,000. But I thought you.
Oh, I probably just made a typo there, right? What should that be?
I just didn't know if that was gonna.
20,000. No, I just made those ahead of time. So when I graph these here in a second, I'm just using those for my labels. Thank you for saying that. I didn't catch that typo. Yep. So here, right? If I had that as 2,000, that'd be a real issue, right? There's no number that would be less than 2,000 but greater than 15. So yeah, I wanted that to be 20,000 there. Any other questions though on that count ifs form before we copy this down? Okay. So I'm going to copy this down. And now I can kind of see, oh, yeah, so this catch-all category, right? I don't have kind of this dramatic fall off in my frequency distribution. I can kind of see that, yeah, there's some that are above 35,000, but like the vast majority are kind of more here in the middle. And I can get a little bit better of an idea about what that distribution looks like in the middle part of that data. Okay. Yeah, so remember I just put like a 1 and a bunch of zeros. So this is a good thing, is I'm glad you asked the question. So if you type in a huge number and Excel can't display it to you, it'll change it to scientific notation, which basically E is like 10 to the power of 18, which just means move the decimal 18 places to the right. So 1 and 18 zeros, right? It'll just, I'm usually just defaults to automatically switching that format to scientific if it can't visually show it to you. Sometimes, I forget, I'd probably have to change the format. Sometimes it'll show up as, here, let me see if I can get one here. Oh, I believe if I set this to number, and then I make this small, if I don't have it set, or if it doesn't default to scientific notation, sometimes it'll show this. Doesn't mean there's nothing in that cell, it just means that it visually can't display it to you. So if you have it changed to that format, oops, you would either have to widen the cell, right, to see that number, or if you don't want it to be that wide, you would just go back in, right click, format the cell. If you put general, it'll default to that scientific notation for you if the number ever gets too big. Questions on that before we keep moving here? A couple more things I want to do before we get out of here today. Okay. So really just one more thing I want to do today. So if I wanted then, so I'm going to widen this cell so you can see that I labeled it as relative frequency, right? So before I do these, or I've got my frequencies. Let's say I want to turn them into relative frequencies. How do I do that? Do we remember? So remember, relative frequencies are just proportions. Yeah, the total number of frequencies, which is actually telling me my total number of observations in the data. Because every observation, if I made sure these bins are mutually exclusive and exhaustive, should only be counted one time. So if I add them all up, that would just be adding up every single observation or the total number of observations. So I can do this two ways. The first is I could just take the sum of all these frequencies. If I've done everything correctly, that should give me the total number of observations, okay? So what's one way we said last class we could check this? Well, we also had this built-in count function, which there's no criteria here. It just counts the cell if it has a value in it. So we go over here, we'll select our very first observation after typing in =, count and starting the parenthesis. Hold Control-Shift or Command-Shift on the Mac. Hit the down arrow. It selects the entire variable or the entire column of data. Hit Enter to kind of close the parentheses and get out of the cell. Sure enough, I didn't make any mistakes here, or at least any egregious errors, right? I'm getting that when I add up my frequencies, they do give me the total number of observations, okay? So the count function is one way to always know that you've got the correct total number of observations. But here we had all the frequencies for our bins. We should be able to just add those up and get the same value as well. Yeah.
Will we need to show that in the assignment, like that we check it?
No. Yeah. So if I did want you to check it, I might say something like, I'm not going to do this, but I might say something like, what's the total number of observations used? If I wanted you to use a specific way, I would say using the count function or something like that. But either way, is if you calculate it either way, I would suggest doing this just to like check your own work. But I wouldn't, I only need to see, as long as you get that total number of observations correct, no matter which way you use, that'd be okay. It's a good question. Any other questions before we keep going here? So the very last thing we need to do, how do I find my relative frequency? Well, I'll just take my frequency for that bin and divide it by the total number of observations. Now I only have to type this in one time because when I copy this down, N8 becomes N9. Okay, so now I'm using the frequency of the next bin. But I always want to be dividing by the same number of observations, right? So if I don't freeze this, it's pretty obvious I'm going to have some errors. Right? I'm trying to divide by, nothing, so it gives me this error, right? So I go back up here, I'm like, okay, what did I forget to do? Oh yeah, I need to freeze that cell reference where I was using that total number of observations because I want to keep using that same value or the value that's in that cell. So now when I hit enter and copy this down, hopefully I get my relative frequency pretty quickly for every single one of these bits. Questions there? If I use that sum function and add up these relative frequencies, if I've done everything correctly, what should those add up to? You remember S is hold up 1, right? So it should be 100% of the data, or the proportion of data we've counted is 1, or a whole, right? Sure enough, we get 1. Okay. So now that I have these relative frequencies, I could use the frequencies, but I'll show you using the relative frequencies. I want to throw them in a bar or column graph. The whole point of all this was, right, to create these histograms. Okay. So I've got my frequency or my relative frequencies now. One nice kind of thing that I was trying to show you last class that we can use. If I have these labels in here and they're not numerical values, like I got some symbols and stuff in there, some letters, I can use these as my labels, right? This kind of lets me know each one of these bins, hold control or hold command on a Mac, select my relative frequencies. Notice it's selected both of those columns at the same time. Now when I go back up to insert, and this is kind of in the way, but right here, there's this column or bar chart. That's what we used last class, right? When we were building our frequency distribution. If I've got my labels selected, now instead of having to go through that process where I change the horizontal x-axis labels, if I create these text labels ahead of time, it throws them in there automatically, right? So that's kind of a nice, easy way I can select those labels as well as my frequency or my relative frequencies. Now I've got my kind of histogram, right? Pretty quick. Any questions on that? So one thing I'll mention in the last minute we have here, and I'll reiterate this again on Friday. We'll finish this up, do some percent relative frequencies, and then talk about cumulative frequencies. There is a built-in histogram tool. I'll show you how to use it Friday. I don't want you to use it for the assignment. I think after Friday, I'll show you a little bit of reason why. If we set it up this way, it's easier to kind of create these catch-all categories, make sure that they're mutually exclusive, but also it allows things to update if we ever want to go back in and let's say, change the number of bins or change our optimal bin length, right? The built-in tool won't automatically update for us. That's why I show you how to do it this way. This is the way that you should be using for that first Excel assignment, which will be up there on Canvas later this afternoon. Okay. All right. Do you have any other questions for me? Feel free to reach out. Leave my office hours as usual this week. Other than that, I'll see you guys on Friday.